Okay, now the second most important trigonometric limit is the limit as x approaches 0 of cos x minus 1 over x. Why? Because I'm going to use it to prove some derivatives. I personally don't care about trig limits other than their usefulness in proving derivative rules. So, again, notice that if we try to evaluate this limit directly, the limit as x approaches 0 of cos x, let's think for a minute. Here's cos x. As I'm approaching 0, then my function's approaching 1. So that's going to be 1 minus 1, which is 0, over top of 0, which is indeterminate. We have some more work to do. So to evaluate this limit, I could go back to charts. I hate charts. I have to remember to be in radians. I have to work through all those numbers. It's tedious. I heard a number of you say today. You seem to like that word, but it is. So I'd like to come up with a different way to do this question. So I'm going to make use of something that we know. Now, I'm going to use that by doing this. Now, some of you are going to say, well, how did you know to do that? Well, because it's going to give me what I want. And unfortunately, in math, there's sometimes a little bit of experimenting and stuff. Now, I didn't ask you to come up with this out of the blue. I'm asking you to see it and notice that it works, and then we'll build upon that. But look what this gives us. James, this is a difference of squares, just as if it was a minus b and a plus b. So that's going to go together to give us a squared minus b squared. Okay, the top is a difference of squares. The bottom we do not expand. We're going to leave it in factored form. So it's going to be the limit as x approaches 0 of cos squared x minus 1 over top of x cos x plus 1. Now, if you wanted to and expanded this with the little arrows, that's fine. You'll eventually get here. It'll take you longer. It's your choice. Now, looking at this, I say, the only trig limit identity that I know, the only one I absolutely know at all, is x approaching 0 of sine x over x. And I know that that equals 1. So if I could get a sine x over x, I could, and the limit was x approaching 0, I could make it equal to 1. So what I notice here is that cos squared x minus 1, if we recall that sine squared x plus cos squared x equals 1, then we can figure out that sine squared x equals 1 minus cos squared x. That's close to what we have. It's not quite. We need to change the signs. So it's going to be negative sine squared x will equal negative 1 positive cos squared x. If you'll forgive me, I'd like to write that like that. But remember, it was a negative 1 and a positive cos squared x. So that means that this thing up here can be changed into negative sine squared. So let's do that. Limit x approaches 0, negative sine squared x over top of x cos x plus 1. Okay, cool. I'd still like a sine x over x. I don't have that. I have sine squared x over x. Let's expand this out using algebra. So it can be a negative sine x. It can be a negative, or now just another sine x, over top of an x, and a cos x plus 1. I can mix and match this any way I want. It's like a JCPenney sale. Mix and match any top and bottom. So what we're going to do is we're going to do the limit as x approaches 0. I'd really like a sine x over x by itself. I could have a negative sine x, and I'm going to have a cos x plus 1. Now you're going to have to spend some time and look at that and make sure that you understand that I broke this up. So it's top times top, bottom times bottom. What I'm now going to do is take the limit of the product So it's going to be limit as x approaches 0 of sine x over x times the limit as x approaches 0 of negative sine x over cos x plus 1. One of these we know. That one equals 1. We know that from what I've done earlier today. The other one we can figure out. As x approaches 0, sine x approaches 0. Cos x is approaching 1. So what we end up with is times negative 0, if that makes any sense, over 2, which is equal to 0. So we know that the limit as x approaches 0 of cos x minus 1 over x equals 0. And I didn't have to use a chart, which I'm very happy of because I don't like using the chart. I like using other math to be able to prove it. So now I know two trig limits that are very important for being able to work out the derivative proofs for trig functions. I'm going to stop there and then we'll do some examples.